Challenges of the 21st century will be the safe destruction of the world's chemical weapons. Hundreds of thousands of these lethal weapons are stored in countries from China to the United States. Thousands more are buried at current and former U.S. military facilities and on the old battlefields of Europe and Asia. Others were dumped into the sea. Through treaties and diplomatic protocols, many nations that possess these weapons, led by the United States, have agreed to destroy them. The Army has been given the mission in the United States, where the weapons are stockpiled at 8 chemical storage depots in the continental U.S. and 1 on Johnston Atoll in the Pacific. Based on technology of the 1970s and 80s, the Army has undertaken an ambitious program of building huge incinerator plants at each of the locations where chemical munitions are stored. The plan is to burn the munitions and agents in these large incinerators. However, this program is encountering opposition from citizens who are increasingly apprehensive of the possible adverse environmental impact of incinerating hazardous waste in general and chemical munitions in particular. Thus far, 4 states have indicated that they will not grant permits to build incinerators at the chemical storage depots. 2 companies, with more than a half-century's experience in solving problems through innovative engineering and technology, have developed a safe, cost-effective alternative to incineration. Teledyne Brown Engineering has been a major systems engineering and systems integration contractor for NASA and the Department of Defense for 44 years. As a result of this extensive experience, Teledyne Brown was selected as the Army's sole contractor for the disposal of non-stockpile chemical munitions and other toxic products at multiple sites around the world. Commodore Applied Technologies has spent over 10 years developing a patented solvated electron process that has successfully destroyed 6 of the most prevalent chemical warfare agents in tests at 3 U.S. government-certified laboratories. Teledyne Brown and Commodore have formed a joint venture to pursue the application of solvated electron technology for chemical demilitarization. Known as SET, the Commodore process has already proven itself in large-scale commercial destruction of chlorofluorocarbons, or CFCs, and polychlorinated biphenyls, or PCBs. As many as 1,400 pounds of CFCs a day have been destroyed, and PCBs removed from tons of soils and sludges daily. SET is the first non-thermal, low-pressure technology to receive a national operating permit for PCB disposal from the U.S. Environmental Protection Agency. SET is one of the technologies selected by the White House for the Rapid Commercialization Initiative, a federal program assigned to the Department of Defense to accelerate the application of environmental technologies. Backed by the resources of Allegheny Teledyne Incorporated and Commodore Government Environmental Technologies Incorporated, and Teledyne's more than 4 decades of integrating complex technologies, Teledyne Commodore can provide solvated electron technology as a low-pressure, low-temperature, economical alternative for the neutralization of chemical weapons. The process not only destroys the chemical agent in munitions, it also destroys the explosive and decontaminates the metal containers and the dunnage. All wastes are disposed of in accordance with established federal and state regulations. SET uses metals such as sodium, potassium, and calcium in low-temperature liquid ammonia to neutralize chemical agents. This laboratory demonstration illustrates how solvated electrons are formed when sodium is dropped into a beaker of liquid ammonia. The entire process takes place at or below room temperature at low pressure, and the resulting products, common salts and organic chemicals, can be disposed of in approved landfills. The liquid ammonia is recycled. Teledyne Commodore has successfully demonstrated solvated electron technology, neutralizing nerve agents, mustard, and lewisite at 3 U.S. government-certified laboratories. After each test, no remaining agent could be detected by the most sensitive equipment available, exceeding the Army standard of 99.9999% destruction. This demonstration illustrates how quickly the reaction takes place. A solvated electron solution is in the reactor vessel at the left. When a chemical similar to mustard agent is injected into the solution, the liquid in the tube at right changes color, showing that the solvated electrons neutralized the simulated mustard agent almost immediately. Understandably, strict safety and security regulations prohibited our filming the actual tests, but successful results have been obtained on the 6 actual agents that are the most prevalent in world chemical stockpiles. In a large-scale test conducted in this commercial-scale reactor at a Commodore facility in Ohio, 100 pounds of nerve agent simulant was destroyed in 48 minutes by the SET process. Sodium and ammonia are mixed in this solvation reactor, then transferred to this process reactor where the agent is introduced and immediately destroyed. The resulting slurry is transferred to a separator, and the ammonia recovered and recycled. This animation illustrates the process in simplified form. Sodium is stored in the tank at left. The sodium is transferred to the solvation reactor where it is mixed with liquid ammonia to form solvated electrons and is introduced and neutralized. Then the slurry of neutralized agent and ammonia is transferred to the separation reactor. Fluid jet technology, incorporating a solvated electron solution, could be used to cut open chemical munitions, drain the agent, and decontaminate chemical agent contaminated surfaces. In addition to bulk agents, SET tests also effectively decontaminated bulk material, such as charcoal used to filter agent from air released to the atmosphere. Teledyne Commodore's patented solvated electron technology is available today as a cost-effective, low-temperature, low-pressure alternative to the incineration of chemical munitions. The unique SET process accomplishes the entire chemical demilitarization mission, which includes the destruction of the agent and explosives and the decontamination of metals in the shell bodies and packing materials contaminated by chemical war gases. This process is highly effective and far less dangerous to the environment than any foreseeable alternative technology.